Okay, so welcome back to my YouTube channel, Does Anything Anywhere, and in this video, we will see some questions related to physics, electrostatics chapter. So, here you go. The first question is if a body has positive charge in it, then it means it lost some electrons. Due to lack of electrons, body gets positive charge. Shear check for presence of electric charge is repulsion between the bodies. Because attraction, process of induction, we know what is process of induction. If you bring a charged body, suppose this is a positively charged body and this is a neutral body which has all plus, minus, minus, plus charges. So if you bring a positively charged body, what will happen? You will see here all negative and here all positive will be. That's nothing but induction. That doesn't, let you help know. Oh, okay. So you need to just check if the bodies are if they are repelling, then it's nothing but this thing. It's charged body because attraction can be between the similar charges and even neutral bodies being attracted. So you cannot say if suppose if attraction is taking place, it doesn't mean that it is charged body because even neutral body is also helping in knowing the neutral body is also attracted. So you can see, due to similar like charges, repulsion force is possible, but attraction force may be due to an uncharged body as well. Okay. So our next question is: if a solid and a hollow conducting sphere has same radius, then option three is correct. Both the spheres will hold same maximum charge. Excess charge spread on outer surface only from their properties, not whether it is a solid or a hollow thing. Okay, when a conducting soap's bubble is negatively charged, then it expands. Okay, due to repulsion force between diametrical opposite walls, the conducting soap bubble is when it is negatively charged, it expands. Five balls marked A to E are suspended using separate threads. Pairs B, C, suppose this is B and this is C. Pairs B, C and D, E show electrostatic repulsion, while pairs AB, this is AB, and CE, this and this, and even AE, they show electrostatic attraction. So when CE show attraction and AB show attraction, it means when AE also show attraction, means BC also showing attraction, the ball marked A must be uncharged. When a plastic rod rubbed with wool, is brought near the knob of a negatively charged gold leaf electroscope. The gold leaves are dilate. See, we have an experiment, gold leaf experiment in your NCRT books. If you just go and refer the experiment, you will get to know. Coulomb's law is analogous to, okay, this I'll just hide. Newton's law of gravitation. Okay, so what is Coulomb's law? It's nothing but Q1 Q2 by R square. And what is Newton's law of gravitation? G m1 m2 by R square. So both are inversely proportional to the square of this radius. Just let me erase this stuff. Okay. Yeah. So here you go with the option. So it is C. Coulomb's law and Newton's law of gravitation are inverse square law. Now, 2 point charges Q1 and Q2 exert a force F on each other when kept certain distance apart. If the charge on each particle is halved and the distance between the two particles is doubled, then the new force between the two particles would be. So the point charges Q1 and Q2 exert a force means you can apply this Coulomb's law F equals to K Q1 Q2 by R square. But they are saying they're kept it to a certain distance mean R. If the charge on each particle is halved, means if suppose it was q dash 1 is nothing but q1 by 2, q dash 2 is nothing but q2 by 2, and the distance between the two particles is doubled, means r equals to 2r. So you can just write k equals k q1 by q, sorry, k q1, one second. Okay, fine. So yeah, so you can write this as, let me just change the color. Okay, so you can write this as k q1 by 2 q2 by 2 by 2 r whole square. Right? It's doubled. So you can write k q1 q2 by 4, and then this 2r square will become 4r square, and this 4 will come up, so you get k q1 q2 by 16 r square. And we just now we know k, q, and q2 is nothing but q. This is nothing but f. So f dash is nothing but f by 16. Okay, just understand that. So yeah. So your answer is f by 16, the fourth option. So your answer is fourth. Okay, now next is two equally charged identical small balls kept some fixed distance apart. So they are equally charged means q r distance apart, exert a repulsive force on each other means repulsive force is in each other means it's plus q and minus q. A similar uncharged ball after touching one of them is placed at midpoint of line joining the two balls. Force experienced by the third ball is, so the force remains constant. So you get answer as F. Okay, the force remains constant. Okay, yeah. So next question is two equal points A and B are at a r distance apart. A third point charge placed on the perpendicular bisector at a distance t from the center will experience maximum electrostatic force when. So you need to remember this condition whenever they are asking you for the maximum this thing. This is important. df by, you have to differentiate. Okay. So yeah. So what that's in the two equal charges. So there are 2 point charges. This is something so q and this is q. They are both are equal means positive or negative, and charges a and b. So they are giving us a. It has a and b. Okay. A distance or something apartments are we will take. A third point charge placed on the perpendicular bisector means from here there's a perpendicular bisector. Suppose this is C, or here it is kept. Okay, there's also a perpendicular bisector means this two gets equal. We know this, so it will be r by two and r by two. All right, and they are saying that perpendicular bisector, what point charge at a distance d, so this distance is nothing but d, it's given from the center. This is your center will experience maximum electrostatic force when. So you can just join this. When you join, you get triangle. So just get this. This is 90. Okay. So you can by Pythagoras theorem, this is d and this is r by 2. You get under root d square plus r square by 4. Here also same, you'll get under root d square plus r square by 4, right, by Pythagoras theorem. And then this f will go, this will become your f, and you have for this you have f, and for this also you will have f. The repulsive force, I think is the okay. So the two equal charges at distance at the third point. Okay, so equal charges means they repel each other, and that's why it will go there and this will go there. Okay, so you get this f1 is equals to f2, so you get kq square, this will be equal, and then f(n) equals to, so here you will get, see, if you just see the diagram again. Yeah, one second. So this is your q and this is your q, and here will be your small q. Here you're joining and this is your f. So what will happen here is, suppose this is your f sine theta and this will be your f cos theta. Same will be like this. This will be your f cos theta and this will be your f sine theta. Equal and opposite forces, they cancel each other. You get 2 f cos theta. F1 cos theta, F2 cos theta, both are equal to 2 F1 cos theta. And then you substitute this. This is nothing but this is not half. This is d square plus r square by 4. Under root will be there. That under root we are keeping it as power half actually. We are removing this under root and we are keeping it as power half. Okay, we are keeping it as power half. And this 2 is there. F1 ka value we know, we put this, and then this d by d square plus r square cos theta, adjacent by hypotenuse. Just do that, you get it. So then again, if you differentiate, just follow the whole thing, you get r by 2 root 2 is your answer. So r by 2 root 2. Okay. Yes. Okay, so next question. Let's go with the next question. Let me just erase this. Sorry for delaying. Yeah, so our next question is a charged gold leaf electroscope has its sleeves apart by certain amount having enclosed air. When the electroscope is subjected to X-rays, then the leaves they again start collapsing. So here again that experiment you have to study. Remember, whenever they are subjected to X-ray, they start collapsing. Okay, understood. Now, two equal positive charges Q are fixed at point a comma 0 and minus a comma 0 on the axis. An opposite charge minus Q at rest is released from point 0 comma a on the axis, y axis actually. The charge minus Q will be, so it will be showing oscillation. So yeah, it's option 4. In question, net force on Q is not proportional to X. So see, all oscillations are not SHM, but all SHMs are oscillations. So you cannot just go with third option, it can be wrong. So they said there are two positive charges, equal positive charges. So plus Q, x equals to minus a, and x equals to plus on x-axis. An opposite charge minus q is at rest is released from 0 comma a. So this is nothing but a 0 comma a. On the y-axis, the charge minus q will be what? It will be executing periodic motion but not SHM. Okay, just solve it, you get it. Now, next. Next question. Wait, I'm so sorry. Here. Four charges, each equal to q, are placed at the four corners of a square, and a charge q is placed at the center of the square. If the system is in equilibrium, then the value of q is nothing but what? Just solve it, so it's very easy. There are four corners. Charges equal q means equal charge given q, q, q. You get q, 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 q. So four corners and charge q is placed at the center. So here you have the center q. If the system is in equilibrium, the value of q is the net force of q on q due to the other charges is 3. F3, this is F3, and whenever see, this F1 is F2 are perpendicular to each other. So whenever the perpendicular to each other, you get a square plus b square. So you're getting f1 square plus f2 square, which is both will be equal to 2 under root 2 f1. If we just see kq square by 12 square. Okay, F3. Just see this F3. It is resultant of these two forces. So KQ square by L square. This is your length, this is your length, so length square. Plus, what is under root 2 F1? What is F1? This is F1 means it is for about this and this. Okay, so it is under root will be this only KQ square by L square. Okay, force on Q1 due to force on Q1 due to center charge minus Q will be what? F4. Here you have F4. This is your F4. So F4 KQQ by L square into 2. Okay, so Y2 means under root 2L. So that gets cancelled. Under root 2 into under root 2, which is 2 you get. This thing you get. So under root 2. So F net this because here you were getting Q square because this charge and this charge. Okay, but for this thing for F4, this is F4 if you see. For this, you need to see if this is the F4, then what are the two charges? Q and Q will be there. So Q small q capital Q by L square into 2. If net force on corner charge Q is 0, then F1, 2, 3 plus F4 equals to 0, and you get the answer as this minus Q by 4, which is option 2. Option 2. Okay, clear? Let me erase this because I don't want to keep it as a mess. ठीक है हो गया erase. ठीक है अब दूसरे क्वेश्चन पे जाते हैं. The next question is which of the following is not true about electric charge? So option 4 they are saying it as correct. Let me just see charge and first option charge in a body is always integral multiple. We know this quantization of charge. This is the first option. Charge is scalar unit, yes. Net charge on an isolated system is always conserved, yes. Charge can be converted into energy and energy can be converted into charge, no. A rest charge, because a motion charge may be converted into energy, but if a charge is at a rest, you cannot convert it into energy. Since they didn't mention whether the charge is in motion or rest, that's why fourth option is wrong. actually. Okay, understood. Next. Uh, Next question. What is the amount of charge possessed by 1 kg of electrons? So we know mass of electron. Okay. See, mass of electron we know 9.1 into 10 power minus 31. Charge of an electron 1.6 into 10 power minus 19. So charge due to 1 kg will be what? Divide them and you get the answer as option 1. 1.76 into 10 power 11 actually. Now, next question. According to Coulomb's law, which is correct relation for the following diagram? So, both charge should be unlike charges. See, uh, here by seeing the forces you can see they're attracting each other means they should be unlike charges. Okay, that means one will be q, one will be plus q, q2 will be minus q. So q1 q2 will be what? Q into minus q will be what? You get minus q square. Q1 q2 is negative, means it is less than 0. Sorry, here if we keep q1 q2 you get it as less than 0. So your option is this, q1 q2 is less than 0, option 1. Is that clear? So simple. By seeing the diagram, see the direction of forces. They're not going outside. It's not showing you like this. They're not showing you like here it is Q1, here it is Q2, and this is the distance. And F1 is going here and F2 is going there. They're not showing like this. If they show like this, then they're of same means you get only plus Q, and then they say that there is positive, and then you get the this thing, this option you get. When they show the forces are in this direction. When forces are in this direction, then you get the first option. Okay. Yes. Now my next question goes like, okay, 1 second. A charge q is to be distributed. A charge q is to be distributed on two conducting spheres. What should be the value of the charges on the sphere so that the repulsive force between them is maximum when they are placed at fixed distance from each other in air? So it's very easy. Uh, Okay. So a charge q is to be distributed on two conducting spheres. What should be the value of the charges on the spheres so that repulsive force between them is maximum? Force between both, suppose you're taking one q and one is other, a charge q is to be distributed on two conducting spheres. So if one is q and other should be q minus q. Okay. All right. If f equals to maximum, then again just we just did this previously also somewhere. We just did it somewhere. We did know like maximum when it comes we need to do it like that. Let me just yeah, here you see, me just increase the thickness and let me just change the color. So here this is if f is maximum, then actually df, this will be here also you're doing the same stuff. What? Yeah, here. Okay, all right. So now if you differentiate q equals to q by 2, so charge will be q by 2, q by 2, option 1. Next, a point charge q1 exerts an electric force on second point charge q2. If the third charge q3 is brought near the electric force, it remains unchanged because electric force between two charges do not depend on the third charge. It doesn't depend upon the third charge. Whatever the electric force, it is attractive, repulsive. If third charge is brought, nothing will affect. Okay. Three charges plus 4q, q and r are placed in a straight line of length l and points 0, l2. So x equals to x at x equals to 0 it's plus 4q. At x equals to l by 2 it's capital Q. At x equals to l it is small q. Distance away from one end respectively. What should be q in the order to make the net force on small q to be 0? So f naught on q is k 4q q cube by I l square plus 4 q q q q into 4 by L square. Okay. If f equals to 0, then q equals to minus small q. Now, the next question is a particle of mass m and carrying charge, okay, minus q1 is moving around a charge plus q2 along a circular path of radius r. Find the, it's very easy. See, we know there's a circle, its radius is r, this is a tangent drawn, here it is m, the minus q will be there, charge, and q2 at the center is given, it seems, right? What did it say? Around a charge plus q2 along a circular path, it's moving with radius r. Find the periodic revolution of charge minus q1. So of the circle we know that it is mv square by r, right? So then k ka value is 1 by 4 pi epsilon naught q1 q2 by r square. What do you need to do is, what they did here is just math solutions, math students, it's very easy. So let me just thickness को पतला करके यार explain here. So M V's, okay, you cannot see only if I do it. Let me choose one color. Okay. So M V square by, so 1 by 4 pi epsilon naught. So what they do is, see this M is in multi, so here it is mv square by r. By in the denominator they had q1 q2 by r square. That k is also there. I can also see that the r square. R and the square gets go, it goes. Then k ka value, k q1 q2 we know it is 4 pi epsilon naught q1 q2 by, this m will come in the denominator because it is in multiplication, so rm, and this square is there, so under root. It will become under root, but instead of under root, we're writing power half. For one trip, t equals to 2 pi r by v. So r, here v ka value is this. So here it is 1 by v, right? If we remove this, it comes 1 by v. So ulta you introduce. So just keep this terms above and this terms below. So you get this, all right, and then you get the value. Okay, simple. So that is it. Let me erase this question, and then the next question we have, I guess, more three questions maybe. So option one. If you just solve, you get it. So it's option one. Now the next question is, consider 3 point charges P, Q, and R. Okay, so this is P, this is Q, and this is R. P and Q are repelling. Means if suppose this is plus I'm taking and this is plus, both are plus, suppose, because then they're repelling. While P and R are attracting. Means P and R means R should be negative, suppose. Then what is the ratio between Q and R? Q and R, you can see it is attraction. So it is attractive force. Logical. Which of the following processes involves the principle of electrostatic conduction? Induction, it's all of this. Pollination, chocolate making, Xerox copying, all of these. Option 4. Sorry, it's option 4. Yeah. Now, next question. The electric field intensity at a vacuum, at a point in vacuum is equal to option 4. It's a definition of electric field force at a unit positive charge would be experienced there. How many electrons should be removed from a coin of mass 1.6 grams so that it may float in? Okay, we know Q equals to mg, then we know Q equals to Ne, so we are substituting Ne equals to mg, then N mg by E. So we got the value of m, we got the value, we know the value of g, then we got the electric field intensity and E we know. So if you solve, you get the answer, option 1. 9.8 into 10 power 7. The right, the value of m is given here, the value of g, so we know it, and then electric field intensity, and then 1.6 into 9, 10 power 19. That's it. Just apply that and you get it. And the next question is, ABC is an equilateral triangle, charges plus Q are placed at each corner. The electric field intensity at the center of triangle will be. So when they said it is an equilateral triangle, and when they're saying it is all the charges are placed at the corner are equal, when these two terms are given, then remember it is a symmetrical this thing, a symmetrical figure, geometric figure, and therefore it will be always zero, and you don't have to count it all. F net, if suppose there is a square given, and a square means all the sides will be equal, and it's a symmetrical thing. So if everywhere it is plus q plus q plus q means all charges are equal, or they can give you anything, minus 3q minus 3q minus 3q, or they can give you minus q2 by 3 minus q2 by 3, anything they can give you if they are saying all charges are equal, and if they are in symmetry, means if they are a symmetrical geometric figure, then you need to understand that net electric field, that is electric field intensity at the center, will be always zero. This is the point you need to remember, that it comes in synopsis, so you should know this. It's a general point, remember it. Don't have to solve everything. Don't start solving for this question. It's very simple. All right, so here you can see electric charge. Electric charge is the property associated with matter due to which it produces and experiences electrical matter. No need to understand, just understand SI unit of charge is nothing but ampere. Let me just draw. SI unit of charge is ampere. Okay, just let me highlight a bit, look more good. SI unit is ampere, S dimensions is 80. This is very important for your J. They can ask you dimensional formulas. And then in an hour, it is 3600 coulombs. And then for this thing, once again, Faraday, it is, why is it not working? Yeah, Faraday, it is 9,000, sorry, 96,500 coulombs. All right, charge is a scalar. Just now we saw that charge was scalar. It is a scalar. It's not a vector. It represents excess or deficiency of electrons. Charge is transferable. It is transferable. Okay. Yeah, charge is always associated with mass. Mass cannot exist without charge. Mass can exist without charge, but charge cannot exist without mass. Remember that. And then when body is given positive charge, when body is given positive charge, mass decreases. Why is it not working? Bhai? Okay, so positive charge. One second, it's not working. Actually. Maybe this will only work. Yeah, it's working. Highlighter is not working. I don't know why. So positively charged. Yeah. So positively charged. Okay, why is it not working? I'm not understanding. Not a problem. Leave it. I cannot focus on this song. Let me just increase the thickness, maybe. Yeah. No, actually not. It's not. It doesn't want to work. I guess it's not working. It is working, but now I'm trying to tell it. Okay, I'm just doing this thing. So yeah, now I will erase it. This whole will go actually. It's a stroke eraser again, resulting into nuisance. So positive charge, it's mass decreasing, and if it is getting negative charge, it's increasing. Okay, no, it's not. Now I won't waste time. Now charge is quantized. We know Q equals to any, where n is any positive integer. All right. Just a second. If I do here, yeah, actually, my position of the laptop, I mean the screen. If I'm going down, it's coming. No, it's not. I didn't. Okay, so Q equals 20. Now, no charge on a proton equals to minus charge on an electron. Just remember this, the value 1.6 into 10 power 19, this value, minus 19 coulombs. Charge is conserved. We know this. Charge is conserved. Charge is invariant. Charge is invariant. Accelerated charge irradiates energy. So V equals to 0, that is at rest, produces only E. V equals to constant, produces, means it is at rest, means it's V equals to 0, it's produces only E. V is any number, then it produces both E and B. And V is not a constant and neither 0, then it produces only E and B radiation energy. If it is B equals to constant, it only produces energy and not magnetic field. B is nothing but magnetic field, but no radiation. Sorry. Huh. I don't know what's happening today. Okay, so this is the thing you need to remember. Now, similar charges repel. We know similar charges repel. Nothing to learn about that. Now, next, These are the questions. We can do questions later. So just remember, just see this question once. It's very simple. If